Is that how I say it right? James. James. Terrible? No, tell me your last name. Reeves, right? Hey y'all, sorry for the change. There's one over there, there's one over there, two more over there. Mom? Mina? Lauren? Lauren, it's Lorette, right? Sonia? Yeah. Logan? No. Tell me.
Race.
Huh?
Race.
Race bourgeois.
Yes, sir.
Yeah. All right. Oh, Ashley. Okay, I think I have everybody here. Just make sure as you leave that I do have you. Oh, and Lauren, I have you too. There's another Lauren.
I'm virtual for this.
Virtual, yes. Testing, 1, 2, 3.
I can hear you loud and clear in the Zoom.
I was testing for something else. Thanks.
Testing, 1, 2, 3, 3.
Okay, so you guys ready to get started? Listen, I can go through some things, but I'd like to sort of hear your questions. But first of all, there are 28 questions on the test. It'll be on Respondus Monitor, but if I emailed you today, I emailed those students that want to take it in the class, then just if I didn't email you, that means I'm not expecting you, then please let me know if you are going to come. It's about half projectile motion and half free response, or half 2D forces. So I think there's like 13 and 14 questions on projectile motion, and then 2D or not just 2D forces, but the laws of motion. And then within the laws of motion, there are probably 4 or maybe 5 2D problems, and then 3 or 4 1D problems, and then a handful of conceptual questions. That's similar too for the projectile motion. For the projectile motion, there are about 5 calculations. Those are problems where you have an object that goes like this, or you have an object that goes like this, and then when you have an object that goes like this. And in that latter part, that's going to be a problem where I'll give you the time, or I'll give you something to make that problem just a little simpler, like we did in class. In fact, the projectile motion, you know, a lot of what we did in class is going to be on the test. Most of what we did in class is going to be on the test, the different types of problems that we've done. Okay, are there specific problems that you would like to look at? Emily?
Can you do 22 from fall 2018?
Sure, 22 fall 2018. We're looking at entirely exams 2 for this exam. Sometimes you'll see work on those exams, and that's not going to be on your exam. And sometimes you'll see vectors on that exam, and that's also not going to be on your exam. Let's download this. "22" you said, right? Okay, a 60-kilogram swimmer pushes on the pool wall and accelerates at 4 meters per second squared. The friction experienced by the swimmer is 100 newtons. What is the magnitude of the force? This was a lot like that problem where I said you have this force acting on this block and causes it to accelerate at such and such an acceleration, which was slower than what it should have been. And then I asked you, what is the coefficient of kinetic friction? This was kind of like that problem, except there's no friction in it. With this, really with all the problems, the best thing to do first is just to draw a picture. And so there's a guy swimming, pushes on a wall with a force. So that'll be my force F. And then the friction force is going to be a force of 100 newtons. And I know that this swimmer has 60 kilogram mass, and that it accelerates him at 4 meters per second squared. He's accelerating in this direction. I draw a picture, I label all my forces. I don't need to resolve forces because, you know, they're all on the x-axis. And then I apply Newton's second law. The sum of the forces is equal to the mass times the acceleration. The sum of the forces is going to be F minus 100 newtons is equal to 60 times 4 meters per second squared. So F is going to be 240 plus 100, 340 newtons. And so the force required to push off and have that acceleration is going to be 340 newtons. That's a good problem, and you'll see a problem similar to that on the test tomorrow. A 1D problem where you have to go through and figure out what is this missing force that's causing this motion. Is that clear? Yeah. It's the same procedure every time. I'm drawing the picture. I draw my object. It's a swimmer or a block or whatever. And then I show my forces on it. I have one force. This is the force pushing off the wall. It's in this direction. This is my resistive force, or the frictional force, the water pushing on them. And then my acceleration is to the right. That's step number 1. There is no step number 2 because they're already resolved. This is step number 3. And then this part is step number 4 where I'm solving it. Draw, resolve, apply Newton's second law, and then solve the equations. Okay? All right, what else, folks? Yeah, Mark? 23? Yeah, I think there is a problem like this on the test. Is that right? I don't remember. As I said, if I say that, there's a question like every question on this test. I would expect any question that you encounter to see one similar to it. Okay, here, we did one like this in class. It was in your workbook. I'm going to skip ahead and do it a little more simply because what we know from what we did in class is that these two forces are identical. That these two tension forces are identical. And then I have another force that's acting downward, the weight. I know that weight, by the way, Fw is equal to mg, is going to be 220 newtons. And I want to figure out what is the tension force. Now, my coordinate system looks like this. These angles right here are both 60 degrees, 60 degrees. The next step that I would do would be to resolve the forces onto their x and y axes. So I have Fw, I have Ft cosine 60, Ft cosine 60. And if you remember in class, I'm going to go ahead and call this 2 Ft sine of 60. The 2 comes about because I have 2 vectors that have the same magnitude. I have the vector from the left and the vector on the right. So I'm just going to call that 2ft sine 60. If I want to know the tension, great thing about these problems is the static problems is I can just say these forces have to equal these forces because 2ft sine 60 minus Fw have to equal 0 because it's static, because it's not moving or accelerating. So I say 2ft sine 60 is equal to the weight, which is 220 newtons. And so Ft is 220 over 2 times sine of 60. I don't know what that is right off. 110. It's 130 newtons. Okay. Can I just write down the equations that you need for the test tomorrow? Is that okay? All right. I just want to, there aren't that many equations really. I have our 2 kinematics equations. Y equals V naught y times t plus 1/2 AYT squared. And then Vy is equal to V naught y plus AYT. I guess this is an equation. I'll write it. But your x components and y components, Vx is equal to V naught cosine theta. I don't really think of these as equations. I just think of these as something that you know how to do, right? That you know how to find the x and y components of a vector. And hopefully you do. Like, that's second nature for you now to find the x and y components of vectors. So we have those 2 kinematics equations. Remember, we had sisters to those equations for the x-axis, and they were very similar. It was just x equals vxt, and that's it, actually, because in the x direction, the acceleration in the x direction is 0. So these equations become a lot simpler for projectile motion. And then for chapter 4, we had F equals ma, and we had script F, the frictional force, is equal to mu times Fn. And that'll change whether it's S or K, the static or kinetic friction. That's it as far as equations. We have our 2 kinematics equations and a variant of them where Ax is equal to 0. And then we have, our x and y components here. And then we have from chapter 4. This is all we have from chapter 4. Now, embedded within all that in the vector math, that's what really makes chapter 4 hard, is doing the vector math, figuring out, okay, what are the sum of my forces? What is the mass times the acceleration? That's why chapter 4 is difficult, because we're beginning to pile up all these ideas in the same chapter. Okay? But you can do it. Like, I know that students will have a perfect score. I'm pretty sure. I hope that students will have a perfect score. So it's doable that you can do this test. You can do really well on it. Okay, exams. Look at old problems. Any particular problems you want to look at? Sure. You're going to have a problem like this, right? You will absolutely have an inclined plane problem. I actually had 2 different inclined plane problems, and with this sort of slightly different scenarios, but they're very similar too. You're going to have a question like number 28 too. It's going to look a lot like this. It's just the equations will be different. Actually, this looks a lot like your exam. If you want to know the truth, all the exams look a lot like your exam. So those are great places to practice. I would sit down tonight and just work through an exam, see how you do, make a 95% on it, and go to bed. Don't go out. Don't do whatever it is that you do at night. I don't know what y'all do, but just go to bed and get a good night's sleep. Okay, so what is the acceleration of this block? The surface is frictionless. That means it's a lot easier. Look, I don't give you the mass of the block, and that might sort of throw you for a loop, but let's just continue on, trust in the process, those 4 steps, and then we'll see that the mass doesn't really matter. So I'm going to draw my forces. I have Fw. Here's Fn. And that's it. Those are the only forces I have. I'm going to resolve the vectors. I have Fn pointed up. By the way, my coordinate system now looks like this, and this angle is 90 minus 60, or 30 degrees. The components of this FW vector are going to be in the positive x and negative y direction because it's in the fourth quadrant. So FW has a negative y component, FW sine of 30, and FW cosine 30. Now to find the acceleration, I know this thing is accelerating in this direction. To find the acceleration, I do the sum of the forces in the which direction, x or y? Do I look at the forces in the y direction or the x direction in order to find the acceleration of this object? In the x, right. So I do the sum of the forces in the x because it's going to be accelerating, along the x-axis. And that's just going to be FW cosine 30. There's only one force acting in that x direction. So I say FW cosine 30 equals to m times a. This is mg cosine 30 equals ma. So the m's cancel, and a is equal to 10 times cosine of 30, which is going to be 8.7 or 9 meters per second squared. So actually, like for pre-med, that's probably something that you just want to know, that you sort of want to know. And when you start practicing for the MCAT, then you'll find these little tricks. That there are a lot of different equations that you can memorize that might help you to just be quicker. But this is one of those, that the acceleration down an inclined plane is just the x component of the acceleration due to gravity, if there are no other forces. But I really prefer just to stick to the process. And then the process always works. And you don't really have to memorize any equations, just those 2 or 3 equations. Now, you want to do 27 as well? You're going to see it. Let's just do it. So let's imagine that that block is 2 kilograms. And the coefficient is 0.2. What is the acceleration of the block? By the way, what happens to the frictional force as you increase the mass of the block? Does the frictional force go up, go down, or stay the same? If I increase the mass of the block, what happens to the frictional force? Up, down, or stay the same? It's going to go up because the normal force goes up. That means that the frictional force will also go up. Okay, so I'm going to work it off here to the side. If the mass of the block is 2 kilograms, what is the acceleration of the block? I'm going to add in another force here, which is our kinetic frictional force, and that's going to be right there. In order to find that kinetic frictional force, which I need to find the acceleration of the block, I need to now find the normal force. And looking now at the y vectors, I can say that the normal force is equal to FW sine of 30, which is equal to 20, right? F is equal to mg, FW is equal to 2 kilograms times 10 meters per second squared times sine of 30. That's equal to 10 newtons. That is the normal force. It's less than the weight of the object because on an inclined plane, the normal force is less than the weight. It's on that inclined plane. And then to find the kinetic frictional force, I would say Fk is equal to 0.2 times Fn, or 2 newtons. So now, as I look at the sum of the forces in the x direction, that's going to be Fw cosine 30 minus Fk is equal to max. Can y'all see? You can sort of see this? I'll try to stay on the white. So that's going to be 20 cosine of 30 minus 2 is equal to, the mass is 2 kilograms times ax, and I'd solve that for ax. I get 7.7. Is that right? Yeah, that makes sense because over here where I had no friction at all, it was 9 meters per second squared, and at least now it's going slower. So that's not an unreasonable answer. Let's see if that's one of the options. 7.5, is this an old exam? Make sure that's the right answer. 27, you see? Yeah, I must have rounded somewhere differently, but all right. Okay. Yeah, Sonia?
How did you get 0.2
For mu, look, it was in the problem. I say the coefficient of kinetic friction is equal to 0.2. All right. Yeah, it's down there at the bottom. All right. Can y'all identify the equation here? Let me zoom in just a little bit. Identify the equation that is not correct. What about that second equation? Is it correct? I can tell right away that it's not correct because I have the normal force here and then I have AX. I have the normal force, which is in the y direction, and I have AX, so that's not right. I can probably say that the third one is not correct. Can y'all identify why the third one's not correct? I have a mistake here. Do y'all see it? This is the sign. This should be negative. Or the sign of the second term. The sign 60 is right. This is not right for what reason? It's set equal to 0. But I know that I have kinetic friction acting. In fact, I tell you that it's accelerating. So none of these are right. Students have told me that I give none are correct a lot, but I don't think that I do. So, you know, just go through the problem, work the problem, and don't try to guess what kind of answers I get. Do I do none that are correct a lot on exams? No? Okay, I don't know. All right, clear this? Let's sort of skim up here our particular questions that you might have. All right. 25, you'll see all of these actually. You'll see some like similar to all of these. Number 21, that's sort of like the swimmer problem. Number 19, the elevator problem. Number 20, this vertical friction. Yeah, Ashlyn?
Can I go to 24?
Sure. Same exam?
Yeah.
Yeah, somebody asked me about this the other day. So you have 3 equal masses, each with mass m. You exert a force on one of the masses, and you get an acceleration a. Let me draw a picture. So here's my mass. I exert a force on it, and it causes it to accelerate an acceleration a. And I know this relationship is governed by F equals ma. So what happens if instead of just one of those masses that I actually exert the force on a bigger mass, which has a mass 3m? Same force, but what is my acceleration going to be? If I exert a force on a bigger mass, is the acceleration going to be bigger or smaller or the same? It's going to be smaller, right? It's like you kick, I don't know, a soccer ball and it goes pretty far, but then you go and you kick a refrigerator and it doesn't accelerate hardly at all because its mass is just a lot bigger. You can see that in this equation, that if I keep my force the same and I triple my mass, in order for this equation to still be correct, I'm going to have to third my acceleration, because then these terms will cancel out. So that means that my acceleration is going to be 1/3 of the original acceleration. Good question. And you'll see, guess what? You'll see one like it on the test tomorrow. Everything's on the test. Actually, it's not common for me to not share exam 2 with either vectors or work. Like usually there's this extra little topic, so I have a little extra space in there to give additional problems, which is good. Fewer than 28 questions is not good for y'all. It's just the questions become too valuable. So I say that just because everything that you see on the exam, you'll see on these old exams, you'll see on tomorrow's exam. You're welcome. Oh, you're welcome. Okay, thank you. Good, good. My wife says that I sometimes fish for compliments. Like, don't you like this thing that we had a plumbing issue over the weekend, and it was just like a clog sink, but then it turned out to be something bigger, and then fixed it over the weekend, but it took a few hours. And people don't really gush over a sink that drains, right? And so I'm like, Kaiser, don't you see the sink is just draining? Just the water is just going down. But she said I was fishing for a compliment. Anyway, you don't care about our plumbing issues. So what else in this exam, or do you want to do some projectile motion? Projectile motion? All right, we can come back to forces. Let's go up. We'll just stick with this one. This looks like a good exam. As I told you in class the other day, that you're going to see these various conceptual things. Make sure that you understand what happens in projectile motion. And that is that in projectile motion, I have this object that follows a path like this. The velocity in the y direction starts out big, it gets smaller, and then it goes to 0, and then it increases in the negative direction, whereas in the x direction, it always stays constant. And so I'll ask you various questions about, what happens to the velocity, where is the speed the least? Where is the speed the least in this trajectory? At the top. Not that the speed is 0, the speed is not 0 at the top, it's still moving in the x direction, but it's the least of anywhere else. Where is the acceleration 0? It's a trick question, right? It's not 0. Okay. Okay, all right. He's lurking. All right. The acceleration is never 0, right? Because the acceleration in the y direction is always negative 10. So you'll see questions like these. They're just sort of asking you about projectile motion. Make sure that you know how to identify these graphs, that you can identify the x and the y motion for projectile motion correctly. You are going to see a question like number 5. You're going to see all 3 scenarios for projectile motion, and at least a couple of those will have multiple questions built in. What is the total time? What is the total height? That sort of thing. You want to work a projectile motion problem? Number 2? Okay. You're going to see one like number 2. Here, see, number 2 is not a very good one. Yeah, we'll do number 2 and 3 because those are sort of built in. You'll find that one problem you'll have to find some value, and then the next problem might be something that you've already found. So just keep that in mind. Like, for example, if I give you a projectile motion problem and then I ask you, I don't know, what is the time at the top of the trajectory? You've already found that. So it's really just going back and figuring out what you did previously. So you kick a ball at an angle of 60 degrees from the horizontal, speed of 32 meters per second. At the top of the trajectory, what is the speed of the ball? I always like to draw a picture. It helps me to think about it. At the top of the trajectory, oh shoot, this is easy, right? Because I know that the velocity is all in the x direction. So all I have to do here is to find the x component of the velocity. And so that's going to be 32 times the cosine of 60, which is 16 meters per second. That's Vx. In the next problem, I want to know the horizontal range of the ball. It's the same problem, but I want to know the horizontal range. Since I know Vx, I know that x is equal to Vx times t. So I need to find the time that it takes to get from here all the way over to here, the total time. In order to find that, it's a chapter 2 problem. I imagine this object goes up and comes back down again. In order to find that time, I would say Vy is equal to V naught y plus AYT. I know at the top of the trajectory that Vy is equal to 0. So I'd say 0 is equal to 32 sine of 60 That 32 sine 60 is the y component of the velocity. Minus 10 times t. T then is going to be equal to 2.8 seconds. Now, if I did 16 times 2.8, I would get 45 meters, and that's an option, but that's not right? Because I need to get the right time. It's not 2.8 seconds, but twice that, or 5.6 seconds. This is time at the top. Really, I want to know the total time, which is going to be 5.6 seconds. Over here is 2.8 seconds, and then another 2.8 seconds elapse are giving me 5.6 seconds. So now I can say x is equal to Vx, which is 16 times 5.6, which is 90 meters. Okay? Can I have a question like that? Yes. Everything's on the test. That's kind of nice, because then you don't have to guess what is or what isn't on the test. It's just everything is on it. All right, you'll have a problem like number 4. I think it's actually pretty similar to this, where you have to find the velocity in the x and y directions. Here, Vx is equal to 45 meters per second. That's just given in the problem. I know it's Vx. You can go if you need. I know it's Vx because it's horizontal. And then I need to find Vy is V0 plus AYT. V0y, rather. V0y, though, is 0 here. The reason it's 0 is because this rocket is fired horizontally. And so it has 0 y velocity. Minus 10, that's the acceleration due to gravity, times t, which is 2 seconds, which is negative 20 meters per second. So now I have 2 velocities. I have to use the Pythagorean theorem to find the resultant of those 2. 45 squared plus 20 squared. That's probably, what, 54? No, 49. This is equal to 49. Okay? Be prepared for that. You're going to see it tomorrow on the test. All right? I clear this, yeah? Questions? Specific questions? How about the conceptual questions? Are you okay on that? Like, for example, this number 7. The initial horizontal component of velocity is equal to the final horizontal component of the velocity. Is that correct? It is correct because the horizontal component does not change. The acceleration is 0 at the top. Is that correct? Right, not correct. So yes, correct. No, not correct. The horizontal component is maximum at the top. Not correct, because the horizontal component doesn't change, so it doesn't have a maximum. And then the initial horizontal component is equal to the initial vertical component. Is that true? Not necessarily. So then we would say no. It's possible. There is one angle, right, where those 2 are equal. What is that angle? It's 45 degrees, right? If the angle is 45 degrees, those 2 x and y components are the same. So here I've just D is the right answer. Good way to practice for the multiple choice is that those concept tests that I've put on Moodle, print those out, print them 6 to a page so that you have the question on one side and the answer on another. Fold them in half and you can quiz yourself with them. You can go back and look at these as well. There are conceptual questions there as well. Okay? All right. Any of these questions standing out to you? Sure. Okay, good. This is probably one of the more difficult questions. It's about the same difficulty as the inclined plane problems. But you follow the same procedure. You draw your vectors, you resolve your vectors, you apply Newton's second law, and then you solve the equations. Draw my vectors. Gosh, what are the vectors that I have acting? I have a normal force. I have a frictional force. I know that because it talks about the friction up here. That's Fk. I have this force, which is 40 newtons, and then I have the weight. The weight is equal to 110 newtons. That's 11 kilograms times 10 meters per second squared. I don't know the normal force. In this case, the reason I did this problem is because the normal force is not equal to the weight. And you'll have one or two scenarios tomorrow where the normal force is not equal to the weight. Look at those. It's always when I have a force that's off to the side, like at an angle here. The second step is to resolve your vectors. I'll do it over here. I have Fn. I have F sine of 30. F cosine of 30. Fk and Fw. In this problem, I'm looking just for the normal force. I think there's a second part to this question where I actually ask what is the acceleration. But for now, let's just look for the normal force. To find the normal force, you should be able to identify now that I only need to consider these forces. And then also that because this thing is sitting flat on a surface, it's not accelerating either up or down. So I know that these two forces in the positive y direction have to equal this. So I can just jump right ahead into step 3 and say F sine 30 plus Fn is equal to Fw. Or really, I'd say F sine 30 plus Fn minus Fw is equal to 0. That would be sort of more correct, but I sort of skipped that step because I know that these forces in the positive y direction have to balance out these forces in the negative y direction. Then I can solve for Fn. It's going to be 90 newtons. Okay? The next step in this problem, and you're going to have a problem that'll be similar to this, whether it's an inclined plane or like this, is to find the kinetic friction. If you have a problem and you don't know what the kinetic friction is, I just gave you the coefficient of kinetic friction. Probably you're going to need to find the normal force. Not probably, absolutely, you're going to have to find the normal force. So now that I know the normal force, I can figure out what is the kinetic friction. The kinetic friction is mu k times Fn, and then that's going to be 0.1 times 90, or 9 newtons. That is the kinetic frictional force. So, if I want to know the acceleration, I can say the sum of the forces in the x direction is equal to F cosine 30 minus Fk. That's going to equal max. And I can solve that for ax. That's going to be 40 cosine 30 minus 9 equals the mass, which is 11, times ax. And solve that for ax. It'll be whatever it'll be. But you're going to have a situation like that on an inclined plane. And then I think in a situation similar to this, where you have to find out what is the normal force first, then find out the kinetic or static friction, and then you can find the acceleration or something else about the forces. Good question, okay? I forget who asked that, but is that okay? All right. Any others on this exam, or you want to look at some other exams? Let's look at some others. Let's go to fall 14. Oh, this isn't working. All right, fall 14. No vector stuff. I mean, there are a lot of vectors, obviously, because you have it for chapters 3 and 4, but no specific vector problems. Here's a horizontal horizontal projectile motion problem. Y'all holler out at me if you want me to do one in particular. Here's one ground level to ground level. Problem number 1 probably on your exam. I think it's number 1. Here is another horizontal, finding out what is the X range, like you did in part 1 of that projectile motion lab. Here's a question just about projectile motion. Hang time, forces, anything here stand out to y'all? I will say that on a lot of the old tests, there are problems like number 14. You're not going to see a problem like number 14. That's where you have to use F equals ma to find the acceleration in this case, and then you have to figure out what is the velocity. But you won't see anything like that. You can do that because you're doing it in chapter 3, but you're not going to see that specific type of problem tomorrow. This is a problem like that we did before with the block. This is similar to the one that we did where he said if you have a block and then you make it 3 times as big, what is its acceleration? So you see how all these problems are really repeats of one another? They're just all different, but they're still attacking the same idea and assessing the same idea or skill. If you have a problem like number 19, I think in one of the classes we worked one like this. Don't freak out by the pulley. Not there to complicate it really. The 100 Newton force is really just 100 Newtons right there. So if you have a pulley, all a pulley does when it just has a rope going over it once, all it does is just redirects the force. So you can just redraw that as something like that. And then this problem comes to me like, well, one that we just worked, or a similar one. Okay, normal force there, just stuff about normal forces. Elevator problem, you're going to see something like that. What happens when an elevator accelerates up or down? What is the force that's felt there? Anything there you want me to work? We have questions about them? Jahan? No, which one, Jahan? Number 4. Okay, yeah, so good. This one is similar to one that we worked before, but it's a little bit different. I have this cannonball, and it's fired like that, and I want to know what is its speed, 1 second afterwards. And I know its speed is going to have 2 parts. It has a part that's 10 meters per second, and then it has another part that's going to be equal to Vy. After 1 second, Vy is going to be equal to V0 y plus Ayt. That's going to be 0 minus 10 times 1. The minus 10 is the acceleration due to gravity. And the 1 is the time that it's been in flight. It's in flight for 1 second. So that's equal to minus 10 meters per second squared. All right, so now I have 2 vectors, one at 10, another that's also 10, but in the downward direction. And I want to know the length of this vector. So say the square root of 10 squared plus 10 squared. That's the square root of 216, right? No, 14. Sorry, 14. So the answer is 14 there, 14.1. Okay? You going to see a problem like that? Yes, you will. Everything's on the test. Everything. Okay, John? All right. All right. What else? Ashlyn?
Go back to the 1217, exam 2, number 19.
All right, this is in your workbook. Oh, yeah. It'll sound like a broken record, but you're going to see something like this tomorrow. Look, if this 2-kilogram block had a 10 Newton force acting on it, it should have an acceleration of F over m, or 10 over 2, or 5 meters per second squared. But it doesn't. It has an acceleration of 2 meters per second squared. And the reason is that I have this force acting in this direction, but then I have another force acting in this direction that is slowing it down so that it only goes 2 meters per second squared. So I want to find out what that is. Let me draw my other forces. I have the normal force and I have the weight. This is a really simple problem with the normal force. In fact, I can just say that the normal force in this case, not always, but in this case is equal to the weight. It's equal to the weight because it's not on an incline and there are no other forces acting in the y direction. So Fn is equal to Fw, which is equal to 2 kilograms times g, which is 10 meters per second squared. That's equal to 20 newtons. I did that because I need to know the normal force in order to find the frictional force. So Fk is equal to mu k times Fn. Oh, no, I need to know what mu k is. I'm sorry. So mu k is equal to Fk divided by Fn. So now I know Fn, that's equal to 20 newtons. I need to find Fk. To find Fk, I say the sum of the forces in the x direction is F minus Fk is equal to the mass times the acceleration in the x direction. That is 10 minus Fk is equal to 2 times the acceleration, which is 2 meters per second squared. 2 kilograms times 2 meters per second squared. So Fk is equal to 10 minus 4, or 6 newtons. So I can put that 6 in right here, and that's 0.3 for mu k. I sort of did that a little bit out of order. Let me show you what I did. So step number 1 was right here. I drew all my forces. Step number 2 is to write out the equations. This is one of the equations. The other is to say F minus Fw equals 0. That's the sum of the forces in the y direction. And I did that up here. And then finally, I realized that I'm looking for the coefficient. And so I solve for the coefficient and then find that I need Fk and Fn to find that coefficient, the ratio of those two. And so then I have to set out to find Fk and Fn. Okay? On the test, on the test, on the test. Everything's on the test, okay? Alrighty. If there are more specific questions, I can answer them, but otherwise we'll wrap it up. Let me check our online folks. Oh, hold on, I have a question here. Okay, no, she just had to leave early. All right. Oh, Brandy, any questions?
No.
Okay. All right, we're gonna call it quits. Brandy, I'll have you for credit, okay?
Okay.